Hello and welcome. I'm Bill Wake. We're here working on a program to compare tunes for similarity, and we're to the point where we'd like to be able to play the tune back, just as if a keyboard or something played it, so we can get a sense of the melody. All right. We have a challenge. We're using this audio toolbox, and it's basically, I would call it C-style library. I don't know that it is an old C library, but it sure looks like one from here. We pass addresses to things and get unsafe pointers back and stuff like that. And there's a little complexity in there about getting notes back. Once we've built up a track or a sequence of notes, I'd like to get something back and make sure that they're right. But it's not super clear to me that that's what we get directly. It does seem like there's something to pull back a value or pull back a note. And but it's sort of like a C union. There's multiple possibilities, and you're getting back a bunch of bytes basically. I don't know if we can map those bytes into an existing type in the toolbox, or pull them back as bytes and decode them with our knowledge of what the arguments were and what the MIDI values are and stuff like that. Okay, it's a little risky to do that because we don't really know what there's no inherent promise that this is going to be legitimate and unchanging over time. It could be they have some reserve values in there they might use for other things, or they might change the types or something. It's not a huge risk, but it's a little bit of a risk. Okay, a second approach we might take is we've got our notes that we have in our notation. We decoded it from the ABC parser. So we have a series of events that are notes and rests and, I don't know, maybe other things over time. And we could convert those from a stream of those into a stream of basically MIDI note messages, the signal that goes to the that gets put in the track. And then we can validate that we're generating the right MIDI note messages, but we won't really be able to validate that this track and sequence is formed correctly. It will just kind of stop at the line of saying, okay, as far as I can tell, I've translated my notes to MIDI notes, and make sure the rest is working from there, manually checking it, I guess. Or we could wrap the player. There's music player, music sequence, music track. Probably the player or the sequence, we could wrap them in a new class and send note information to that class, let it build up the MIDI track, and maybe it keeps track of the notes or something. You know, I guess we could do it either. It keeps track of the notes we sent to it, moderately interesting, or maybe we do the reverse engineering there. So kind of combine these. Or maybe there are other ideas. I don't have them yet. Maybe you do. I'm willing to explore. I don't know the perfect answer. What I do know is, at least what I see so far, there's not a good way for me to just easily check these things. And so I've got to draw some lines and make some compromises. I don't really want to make my tests play sounds. Okay, that's kind of the limit of this thing. We want tests that check that we're doing the right thing without calling play. Okay. We got an external connection there connecting to the speaker, and we usually try and draw the line so that we don't actually call those things. For one thing, it slows the test down. For another thing, I don't want to hear these notes over and over every time I run the tests. The slowing down is really obnoxious, though, because if it's a 10-second piece of music or 10 1-second pieces or whatever, am I going to sit there and listen to remember, oh, this is, the theme from Rocky and this one's supposed to be Twinkle Twinkle? No. Okay. So we got a challenge. So let's see what we can do. Okay. Let's see. So we're starting here back at our example. This came from a Stack Overflow question. But the heart of it, at some point, we need to produce MIDI note messages. They have an audio channel that's kind of a MIDI idea. I think if you had, like a bass line and a melody line running at the same time, you could put them in different channels. The note number of velocity is, I believe that's how quickly do you start the note. So an organ, you press the key, the note sounds right away. Piano, it maybe has a little bit of pause. Well, actually, some organs, like true pipe organs, it may take a little while it gets enough air in the pipe to make a sound, Maybe wind instruments have that problem, and string instruments pretty much play when you play them, okay? But it's a little bit of, they call it envelope, and we have the release on the corresponding other side, okay? A piano, you play the note, and it kind of, goes down, 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 down over time. It's a percussion instrument. There's a hammer hitting a string, and when you do something like that, it rings hard at first and then just kind of decays. Where an organ, while you've pressed the key down, it's playing, and when you let go of the key, it stops playing. There's no long trailing off thing. It just depends on the instrument. It's a pretty crude way to do it, but you get it makes it a little more realistic sounding. And then duration. I haven't seen the definition of that yet. I've seen mention of things being beats. And so this may be a beat, and we have to somewhere else control how many beats per minute. And we haven't dealt with that on our input side yet, but maybe this is a chance to do that. On the other hand, we might just like to give ourselves a slider so we can play it fast or play it slow, Okay. All right. So in the construction, we're going to build notes from our events and then build MIDI notes from those and stick those in the track. Okay, so the track is the series of notes, and each one has a time, which is, I believe, the beat number you want to play it at. Okay, and that, I believe, is a float. Maybe you're wrong on that, but I think you can subdivide those and all. Okay. With ours, we have explicit rest, but there's no rest message. You just change the duration. If it's duration 1, started at beat 2 for duration 1, it's going to go from beat 2 to the start of beat 3. If you want to rest on beat 3, you just don't start your next note until beat 4, say. Okay. But that means keeping track of this time as we build up the track. All right. It's going to be kind of a similar loop, except where it's getting these notes. Okay. So now we have a track. Where's the track declared? Music track. Okay. Let's go look at that. And, you see this opaque pointer, meaning I don't want to tell you what you're getting back. Okay. We do have a callback. Interesting. Okay. So we see music this. Let's go find that thing. Okay, callback will call for any user events added to any of the tracks. Okay, I'm not quite sure what they're saying. Okay. All right, let's go back to the track. Okay, so music track is an unsafe pointer. All right, now we want to find well, let's find music track again. See where that's used. Okay, let's use there. Okay, so this one, the music track has properties. I think the notes are in here. No, these are more, track level properties. Okay, so mute and solo. Mute says turn off this track but leave the others running. Solo says turn off everybody else and leave me running. They're very common on recorder, editing decks for giant tape recorders like systems. As you're recording, you might want to find out, how did that one part play? And you just only play that track back. And with the other tracks muted, you can, oh, I flubbed that note. Mute is, let's see how that sounds without the drums. Okay. All right. Let's keep going. Loop info. We're not going to worry about loops. Okay. New music sequence. Okay. Index track? I don't know. Tempo track, interesting. Get sequence. Get the sequence the track is a member of. Okay, so we're working our way up the tree because players contain sequences, contain tracks. Okay. We're not going to worry about destination node. MIDI endpoints. That should all default based on what we saw before. Okay, set property. That's probably all those constants we saw above, looping and mute, solo, and so on. Get property. Yeah, here you go. So you ask for a property, give it a track, give it a property name, and then it gives you back a raw pointer, unsafe mutable raw pointer. I mean, that's about as unsafe and ugly as they get. Okay. And it gives you a length, pointer to the length, and tells you how many bytes you're getting back. Okay. And then you got to interpret those bytes. All right. Editing operations. No. Move. We're not doing moves. Clear. Cut. I mean, this would make sense if you're writing a MIDI editor. New MIDI note event. Okay, that's the one we were focused on. So you take a track and you tell it the timestamp and then the MIDI note message. Okay. And it's giving you a pointer back to the MIDI note message. Which I'm going to back up here. In our MIDI note message, we got the note back. Oh, okay. And then we add that to the track. Okay. Yeah. Get the track back. We probably aren't changing the track. I don't know. What's it returning back? OS status. That seems funny to me then. Music track new MIDI note event. Returns an OS status. That's not a music track. Music sequence new track. I don't think that value is being used. Music track. Yeah, it doesn't get used any. Okay. It really is just a status to tell you if it worked or not, I think. OS status? Who knows? Okay. Music track new MIDI channel event. That's if you want to change from keyboard to violin, you would do a channel event. Okay, you can do raw MIDI. Good. Okay, somewhere we have some gets. Extended events, they're a different kind of event. Parameter. Okay. Extended tempo. Well, interesting. I'm not sure what goes on there. You're giving it new beats per minute. Maybe that's you've defaulted or you've set it at the beginning, but now you're saying, okay, let's speed it up. Okay. Track meta event. Somewhere there was something to get Okay, we can iterate over the events. Now, that might be useful to us. Okay, so you generate this pointer. We'll have to look. Give it a track. It gives you back an iterator. So music event iterator. All right. Oh. Oops. Another opaque pointer. Seek to a specific time point. Just get the next element. Yeah, that's the kind of thing I'd like to do. Walk through these, and then so next event, let's move to the next event, move to the previous event. How do I look at what I'm seeing? Get event info. Okay, right. Pass an iterator in. Okay, K-music event type. Out of event data described by the event type. See, I think we might be able to, I think this might be the way we get out event data is raw pointer. Optional. Okay. I think this might be, we might be able to put, like, if we know it's a MIDI data event based on this type, we can interpret this as a pointer to the MIDI data event. I'm hoping that's going to work. Okay. Let's see. How do we want to do this? Okay, we've done our documentation research. All right. I guess what I want to do, let's just spike it. Okay, so we got a sequence, wherever that is. Okay, that was created up here. And the sequence contains a track, and the track contains notes. All right, so I would like to, well, I'm not so worried about starting the player. I want to take a look at that sequence. Okay, so music iterator. Let's get back to the first one of those. Okay, so let's call this thing. It takes a track. Okay, so our music iterator of music event iterator. Okay, so we provide some space, and then we're going to call this thing. Well, let's just take all this. Music iterator in is the track. Is that a music track? Yes. The out iterator, well, it's going to be I definitely should declare this first. Okay. I guess this is bye. This is our iterator. Is that going to work? Okay, we don't need this in the end. Okay, so let's make this music iterator equals nil. Optional opaque bar must be unwrapped to a value of type music track. Music track question mark. Well, I guess this is track. I think we've done it that way above, right? Yeah, well, it's an N. Okay. Oh. Okay. Now let's print. Well, what can we do with this thing? We don't need to seek. Okay, is it going to point that thing to the first one? Okay, I guess we don't know. Move it to an event. Okay, I think this one, music event iterator, has current event. It will move past the last event. It will no longer point to an event. Okay, I guess we want to print. We want to call this thing. Ugh. I don't even know what we put for this. Out timestamp. I think we can be nil. If you don't want specific information passed in null. Okay. In iterator. All right, we're going to try and make this thing do something. If it blows up because it's not at an iterator event, we'll have to do something. Okay, so this is a music iterator. Bang. Okay, output timestamp null. I don't know why they didn't keep these labels when they mapped it, because they'd be kind of handy. All right, out event type. Well, let's create one. Bytes. I think it's that, maybe. Oh, sure. Let's start out now. Okay, so the event type, music event type question mark equals nil. All right, so the out event type and the event data, we're going to map that to bytes, I guess, if it'll let us. Event 32 is nil. And let's do that. Address of event data size. Okay. Now we're going to print music iterator. And I'm going to break these up just so we can use them or not use them. Okay. Event type dot. Our event types look very not so useful. I suspect that's another opaque pointer. So event types, okay. Enum. All right. Well, let's print it. It's just an enum which was printed as is. Well, let's. Okay. Oh. Can I cover it? Maybe I should say nil here. It's fine. I don't mind the warning and the spike. Okay. Event data size. Okay, if I got that much out, I'd be pretty happy. Okay. Oh, you're not happy. Unsafe. Interesting. That almost seems to contradict this. And I'm just going to do status again. All right, so find this. If you do not want specific information, pass in null. Well, it's not happy about that nil. In iterator, out timestamp is pointer to that. Well, let's just make one. Oh, he's still not happy. Cannot convert uint 8 to unsafe raw pointer. What do we call this? It's not the. How about payload? Okay, is that any better? No. Oh. Optional type music event type must be unwrapped to a value of music event type. Now, timestamp double must be unwrapped to a package. Unwrapped to a value of type. What do I need? Am I messing myself up with this? Oh, apparently so. Can tell how little I use pointers in Swift. Or references. Okay. Oh, he doesn't like payload. Unsafe mutable pointer. pointer to an optional pointer. Like we're going to trust that thing. Connect to value of type unsafe mutable pointer. Address a variable before it is initialized. Event data size. I don't even know. What is music event type? Is that our enum? Yeah. Music event type. Well, let's take this one. Okay, who else? Timestamp. Okay, let's try this keyboard thing. Equals 0. Let's see if that works. I think it's a float of some sort. Yeah. Okay, I don't know why it's not complaining about this, but it's happy with this other stuff. Maybe I had optionals and stuff before it was there. These two should be integers. I guess I could print the timestamp too. What the heck? Right. Okay. Now, I will run. Should get some sounds. Oops. Okay, I don't know if you can hear them, but it did play. Get that a little louder. But this came back, and it's actually useful and meaningful. Okay. We think, okay, I suspect event type 6, I hope, is our MIDI note one. Let's see, where are those? Here we go. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Is that 6? 1, 2, 3, 4, 5, 6. All right, let's just print this. Maybe I should say it the other way. This equals that. Okay, run that again. Eight bytes here. Why are you not running? Okay, I'm moderately happy. Now, this event data size 8. All right, so I'm pretty sure we're getting this MIDI note message, right? Our example used MIDI note message. So up here, we put those in here. So that pretty much should be what we're getting back. Now, how does this map into 8 bytes? All right. Well, let's go look at this type. Okay, I'm feeling good here. MIDI note message. Okay, channel. See, these are all bytes, right? 1, 2, 3, 4, and then 4 bytes there. Okay, so if we can cast this, then we can get that value back. And I think we can print them. Okay, let's see what happens. All right, so this would get back an unsafe raw pointer. Okay, so let's let payload as MIDI note equals I want to say payload. I don't know. Can I do it like this? Payload as where's that type MIDI note message? We got channel. That's not promising. But it takes it. Okay. Channel and note. Ooh. Always fails. Just note. Velocity. Let's get this duration. Unsafe raw pointer. I wonder what if we if I do that? I don't think I'm doing this right. No. So was this an unsafe raw pointer? Ooh. Cannot convert between unsafe types. That's not promising. Provides no memory management. No type safety. No alignment. print address as. Okay, print of address for raw pointer as the type. All right, let's try it. All right, let's try it here. Print address of payload as. Is that how that? Not int. I want it to be MIDI note message dot self. And maybe this is payload bang because it's. Okay, let's comment this part out. I don't know what we'll get. Expected. Oh, extra argument as. Address colon as colon. Address colon this as colon that. Instead of this being int, we're saying MIDI note message. Extra argument. Let's see what we got. Print items. Oh, well. See if we can get through this call. Unsafe raw pointer. Is that what our type is? Unsafe raw pointer. We're doing bang, so it should be unsafe raw pointer. Oh, maybe they defined that. So pointer.load as type. Okay, well that sounds more like what we wanted to do here. So value equals payload dot load as dot self. Okay, I kind of want to let it blow up. Well, okay, it likes it, all right. Okay, let's see what happens. Okay, notice up here, our first note is 60. And we're saying channel 0, note 60, velocity 64, release velocity, and duration. And we pulled out the specifics, but I think the thing here is fine. Okay, so let's clean up a little bit. Timestamp. I'm curious if we can just print the iterator directly too now. All right, so I don't really need this. Well, let's just put it up here. Okay. And then that makes me wonder if we can just do this here. Probably not, but we'll try it. Okay, that didn't add any information. Well, let's... Okay, so I'm feeling good. My worry was I couldn't get these things back out, but I have one here. And I'm trusting that's okay because the type was MIDI note message. If I were using a mix of types, I'd have to basically have a switch statement and deal with the different union of possibilities. I think for now, this will be the only one we put out there, so we can verify it from that. Well, what that also tells me is if it's storing the MIDI note messages, well, whatever it does with them, if we produce MIDI note messages and check those, we're probably in pretty good shape. And if we passed an array of MIDI note messages on from our stored music, if we turn it into an array of MIDI note messages, I think basically this little loop in here, we'll have to do a little work with the time, but they should be right. Okay. We haven't dealt with duration yet. And I'm not sure. Yeah, I'm sure we can do something. Okay. I don't know what sets the duration. There's something that maps the duration. And I don't know. We found everything else though. So, I mean, I'm pretty happy there. Okay. How about speed? That might be a good word. Nope. Playback. Music player controls rate and setting. Okay, let's find music player. Another opaque pointer. Yay. New music player. Okay, creates one. Dispose. Set the sequence. Okay. Get the sequence. Set the time. No, that's not quite right. Get host time for beats. Used when you're in the middle of it. Get beats for host time. Pre-roll. Start. Stop. Is playing. Set play rate. Is twice as fast. Okay. So we can do that on the player and set that in here. Okay, so let's try that. In here before we play. Excuse me. All right, so we're going to call player. Okay, we need in player is player. And scale rate 2 is twice as fast, so let's do 4 times. I think we'll hear that. And they're just assigning this to player, which I think is a little weird, but all right. Okay. Move that var status up. Okay, that gives you a player. Interesting, because it fills in music player. What's his type? Oh, a status. So why didn't that work? Oh, because I'm passing the wrong thing. I want to pass music player. And then this can be player. Okay. Bang. Yeah, this is why I think this is a C interface. Okay, what's your problem down here? Okay. So what I should get is a very fast scale. Hey. All right. Okay. Cool. Okay. Oh. Feeling good. I think we've got it. We got it. So if we produce an array of MIDI note messages and an appropriate speed, we can call player and start the player. Now, how isolated do I want to be is kind of a question. I don't know. So the question to me then is, do I want to produce MIDI note messages or some other object that contains at least a subset of this information? I'm not setting channel and I'm not setting velocity or release velocity. I really just need the note and the duration in beats. Now that, because really I would like to keep how do I say this? The thing that's converting events, musical events in our internal representation to MIDI notes, if I create my own class, everything is isolated. I can create another class that manages the tracks and that takes my array of those things, converts them trivially into MIDI note messages, and shoves them out onto the track. I think I'm going to do that. That's more isolated. I'm passing less information because I'm only passing the stuff I care about. If at some point the channel has to come into it, we'll deal with it. Okay, so let's turn that into concrete things. Okay, so we're going to create a class to hold note and duration. Something converts our events to those. Okay, a player object hold takes those and puts in, how about uses audio toolbox internally to store and play. Okay. And then we can trigger play. Yeah, so I'm doing this isolation, which you could go through and not do it, but then I'm going to leak in potentially everything in this class. I'm going to have to include this import, and it's got 50, 75 calls that I have no intention of using 99% of them or 90% of them. Right. And this way I don't need to do an iterator. I guess we proved you could get the notes back out. But if I produce them, maybe we can use this. The new class that's going to wrap all this stuff, we could use the iterator and check that sequence, I guess. We would check that when we push notes into the sequence, they showed up in the sequence. It might not be worth checking. All right. So I'd leave the equivalent of this really, actually, that my new things are going to contain the timestamp. So, yeah. So it's kind of this loop, and then some of this setup stuff would be hard-coded and not tested directly. It would need a manual test to make sure that the notes played as expected. Okay. Now, am I content with that? Another way to do it would be to make this object make it take our events in the first place. The downside is, well, it's not a big downside, but then I'd be testing on this thing a little more, but maybe that's okay. I don't think it's super hard to do the conversion. Alrighty. Let's go look. We haven't looked at event in so long. All right. Okay. Now, here we got notes, rests, bar lines. I think event may not be the right thing to look at. Event is our stuff from the parser. Oh, and I'm taking these out all the time these days. And if I don't need foundation, I'm going to take it out too. Okay. Yeah, event is not what I'm after. I'm after no. Wow, it's been so long since I looked at this stuff. There's event. Note, what are you? Note. Let's go down tune. Metadata and parts, measure map. Measures to measures. Let's go to measures. Oh yeah, symbol, that's it. There's not a good name for things that are notes or rhythms. Okay. Yeah, so these things, we get a sequence of these. Let's find a usage. Events to parts, that's converting them. That's moderately useful. Okay. Measure. Well, let's look at this one. Okay, so given a bunch of events, it turns it into parts. And parts contains all those symbols. So each parts contains measures, contains the symbols. Measure contains array of symbols. Okay. So if you converted, well, uses this? Note tabulator. We had something that produces just the notes. Is this our statistics? Yeah. No, this is the melody average thing. Yeah, what does it take? Populate tune. Tune.measures. Right. So that maps from the parts, which is things like A, A, B, B, if your tune's like that. And well, in the end, it produces an array of measures. Or you can take the measures and map them down to the symbols. So given a tune, we can get the notes, which is symbols. And that is probably what we want to pass into our converter, our player. Okay, well, we've gone a while. Let's take a break, and we'll come back and start. I think given a symbol, given a series of symbols, you should be able to generate the MIDI note events. And maybe we'll just test that directly. Make that function that converts it more public and validate them that way. Yeah. Okay. So when we come back, we'll start with that. And then we'll do the boilerplate to get that thing into the player and make it play. And I think we'll make a good dent in that this afternoon, maybe even finish. All right. See you in about 3 or 4 minutes. Okay, welcome back. Let's see. During the break, I deleted all those comments at the top of those files and just ran the tests. So we'll just check those in, just delete unnecessary comments. Okay. And playground example. And then we've got to choose, well, we got to find where to put this. I think we have player sound. Okay. Let's call this thing, I don't know. I'm thinking MIDI player. Maybe it's a note player. I don't know. Maybe it's just a player. Or a sound player. Let's try that. So, well, a little backwards here. This goes in both targets. And take that stuff out. But we're going to make a new class, sound player, and do something with that. And then we need some tests. Sync sound. Let's alphabetize these. Oh, I guess I should have made a test case out of that. Sound player tests. Okay. Test. Well, SoundPlayer test switch is part of module TuneSim. No, it's not. I don't think. However, No, it should be part of shared tests. Okay. And we want to, let's just check sequence of notes. What should we be looking for? Sequence of notes yields, I guess, note and duration. Okay, so this time I'm. What is player? Well, let's make the test, I guess. Let player equals SoundPlayer. And we need symbols that are notes. So let notes equal array of symbols. So this is dot note. We may have to say it. Note name is all that's required. Let's just start simple. Note C. Note D. Note E. Okay. Should we pass that in? Oh, I can say note with rhythm. Let's make this one rhythm 2/4. Rhythm 2/4. So these default to 1/4, I think. Extra argument and call. Oh, I gotta say rhythm. Okay, let's make these readable. Extra argument rhythm in call. Because you go inside parentheses. Okay. D's 2/4. All right, so we got 3 notes. Let's give those to this. So we're saying a sound player will create a new one that starts with the notes, and then we're going to get something back from the player. I think it's a series of MIDI pitches and durations. No, it's not durations. It's beats. Okay, so let actual equal player dot. I don't know what we call this thing. Notes. And then we want to say actual sub-zero should be, well, C60? I think it was 64, isn't it? Oh, we lost our playground. '60 is C. Okay. On choice. All right, so we should get 60, 62, 64. And these are MIDI numbers. What? Where? Okay. Running around everywhere. Okay. I'm going to say 60 and duration 1. Actual count is 3. '62 should be 2 because the rhythm. And then this one should be 64 with 1. That's a 1, that's a 2. Okay. Int cannot conform to equatable. That is so stupid. Okay, let's take actual. Let's map it to the first element. I don't know. This is $0.0. This is going to be just the pitches. Should be 60, 62, 64. And the rhythms should be 1, 2, 1. Okay. Well, I'm not totally happy with the interface. Let's find pitch. Did I give myself any clues? No. MIDI note number. Maybe I did something there. Oh, that's just int. Okay. We can do it this way. Public let middle C equals 60. And I think I can say MIDI note number of 60. Like that. Okay. Property can I be... Oh, come on. Nobody uses this? Huh. Okay, I can take this out. Okay, so now I can say pitch.middle C. Make those a little nicer. I don't know if that's super better, but... Okay. Oh, he should be static. Okay, now, while that gets caught up, we're going to say our sound player needs to take an array of symbols. Yeah, I'll call it symbols here. A little more generic. Okay. And nobody does nothing with it. All right. Argument passed to call takes no arguments. Remember notes. This, I'm not going to make it public, but I'm going to make it available. Okay, so this is notes. It's a property. Well, I'm leaving it like this so the test can get to it. Var notes is an array of int. And I'm not sure I like that. All right, but we can, I guess if it's the only thing, I don't need that. All right. We can refine it as we go. Maybe MIDI pitch needs to be a concept, a public concept now. All right, because our player definitely cares about it. It's a MIDI player. Okay, this test should fail. This line will fail and then it'll crash on these, I think. Maybe not. It's an empty list. Yeah, okay, they're just different. Okay, so 0 is not 3. Empty list is not equal to that list, and empty list is not equal to that list. All right, so well, we need to store, I think, let's go back to our playground. Okay, I got a lot more than I want open here. Close tabs to the right. Okay, some approximation of something we can look at. All right, so what I want to do is I want to store these things. And then I want to give them back. All right, so this MIDI notes is array of MIDI note message. Now, I'm never quite sure if I'm allowed to do this here. Oh, import audio toolbox. var. Oh, this is my function convert. It's going to take symbols of symbol, and it's going to return array of MIDI note messages. Return empty for now. Okay, yeah, so I gotta, let's just start empty, and then we do this in a defer clause. So defer says, once you've finished constructing it, then go ahead and call this. Now, this has a complete object to work with. I probably could just make it static. Maybe that would be better. I think that might be better. SoundPlayer.convert. Don't need that. And really, this is, I'm mixing producing the MIDI sequence with the player, and I don't know. All right, this still fails the same way. All right, now convert. Well, let's do the simplest thing first. Let's say MIDI return, take symbols, map them to well, let's just map them to MIDI note message channel 0. Note is symbol dot. We gotta, yeah. Oof. Let's see. Let's take symbols dot filter is note. So we're only going to keep the ones that are notes. I'm going to do an incomplete version first. Get that first assertion working. All right. Stop. Okay. Filter them and then map them to this. Channel 0. Now this is $0.as velocity default. Oh, let's just plead ignorant on the timing. Okay. So we take each note. Oh, isn't that a symbol has no member as note? That was not my symbol. Oh, pitch. Maybe we need to expose this. Okay. I'm gonna say, let's make this public. Make this uint 8. Okay. Public type is private. Well, now this can do this. Okay, let's force that this way. Well, no, it should be this, really. Okay. Now, that can be .pitch. And we'll see who's using that. Maybe they don't even care. Okay, now, there may be other tests that were depending on negatives or something. I don't know. Yeah, here we go. Pitch.middle C. Well, yeah, that's fine. Do expected type int. Okay, we're gonna have to fix that in here. Symbol, this is MIDI note number. Okay. Now, run that again. This is why it was int originally, because it's just a pain to convert them in and out all the time. All right, the good news is the other tests didn't care what that was. All right, so at this point, we've stored those things, but we haven't looked at them. Okay, so Now we're going to take those note numbers, note messages. So return MIDI notes dot map. Well, we're going to return a pair. So it's $0 dot note is the pitch and $0 dot duration. And let's leave that as that. Okay. So good. That returns what we have, maps each one to its note and pitch, which is what this little helper function does. I don't know. I kind of want to put that over on the debugger or the testing side. Right. Let's see how it does. Pitches should be right, duration should be wrong. Yep. Okay. Yeah, the other thing is we probably need a little fuzz here because it's a floating point. Okay, shouldn't affect that. Oh, do I have to? What do I say for that? Accuracy. Okay, something's a little weird. And it fails. Oh. Okay, I must have option bumped something. No exact matches in call. Really? Well, let's not worry about accuracy. Okay. So this may be not quite right. All right. So what's going on? Well, we've hard-coded the duration to 1, so everybody's always a quarter note, basically, I think. We'll have to check how that defaults out, but whatever the default is, everybody is that. And now this may mean this map is not the right tool here. Okay, so I guess we want to start the duration at 1. Maybe this is, I think I should make my answers be different. I think this should be 1 to 4. Okay, so beat 1, 2 is the start of this, 3 it's still going, and then 4 is the next note. It's clearly not equal to that because it's all ones. Okay, so close some of these. Pitch we've been looking at. Okay, so really I think I need to do more of a for each kind of thing. Is this going to be a reduce? I don't think so. There's probably a way to do it, but okay, we definitely have to do symbols dot for each. Okay, and what are we going to do? well, I guess let's create the MIDI note messages. Result is MIDI note message is empty. Okay. And then in the end, we're going to accumulate we have to accumulate these, I guess. And then we want to keep track of the time. And that's a float 32. Okay. And let's start that at beat 1. I think that's how it's supposed to be. All right. And then $0 pitch pitch. Add one of these every time through. Return result. And I guess this is note. Well, we'll do that for the moment. We have to adjust this when rests come in, but just trying to get the shape of this thing first. All right. Let's do time here. Okay, maybe this is beat. More of a musical term for what's going on. All right, so this is beat 1, 2, 3, 4, 5, 6, 7, 8. All right, and then the beat, well, we've appended the note. The next note is beat plus equals, well, our note. Do symbols have durations? Let's open symbol. They do. They have a rhythm. I'm not quite kosher here, but somehow I want to say $0 is that the ratio? So 2/4 is a half. And then I'm gonna adjust it for now. I don't think this will hold. Okay, that's junk. Okay, cannot convert double to expected type float. Yeah. I guess that whole expression. Okay, so right, so we're going to take our symbols, we're going to filter out the non-notes, and then we mark this. No, his duration has to be that. Okay, let's do that. Equal this. Okay, so if it's quarter notes, 2/4 is a half, times 4 is 2, which is right for quarter notes. Beat plus equals duration. No, this is really... I don't think I'm keeping enough information here. Duration is duration. Beat. Okay, something's not right. This is duration, but where's the beat? Okay, duration. Yeah, we need time. Well, okay, we can call this duration for now. Then this is back to 1, 2, 1. But I don't think that's enough for us. Okay, and we may have gotten it far as we can with this. All right, we got this beat running around, but we're not using it. So I think that's redundant. Let's take that out for now. Okay, so we're appending these things. Those durations come back. We look at them here. All right, let's see how we do. I think this is enough to do that. It's not enough to do the right thing. Not even enough to do that. Okay, what's up? 4 to 4. Why is that 4? So that was a 1. I multiplied it by 4. And then the 2. Maybe I need to multiply it by rhythm ratio. Let's take that off. Is it coming as a half? Now that's really, these are not showing up as a quarter. I should verify what these do. Note, init, where's init? Rhythm equals whole note. Okay. I don't think that's super helpful. So I was kind of taking a default there. Let's make it this. A little more explicit, maybe better in this case. I think it's gone back a quarter, a half, a quarter though. Yep. Right. So the multiplying by 4. I mean, the 4 is there because we're assuming a 4-quarter note pulse, it really is not a valid assumption, I think. All right, but let's get it green. We've been waiting long enough. Okay. So we have hard-coded things, but all right. So add SoundPlayer to track notes and rhythms, notes and durations. Okay, so I think what I'm convincing myself, because I really want to validate these durations, not duration. I want to validate the timing of this thing. What beat are you on? And that requires tracking this, and it means putting this somewhere so we can store them. I think maybe this should be its own type for now. Let's make a type. Let's make it private class NoteInfo. And maybe even struct. This is kind of exactly a struct situation. Okay. It needs the MIDI note number. This, whose type is MIDI note number, I think, yes. Okay. Private note is MIDI note number. Private duration, maybe this is duration is float 32 and beats. No, that's not quite the same, is it? Timing. Okay. We don't need private on these. Okay. Can we store these? Let's say NoteInfo is NoteInfo now. Okay, so this is going to go to NoteInfo. This is NoteInfo. Okay. Well, let's make this like that. Okay, this is NoteInfo. NoteInfo, and in here we're going to put NoteInfo. Note is $0.pitch as before. Duration is duration. Time, let's make that 0 for the moment. We're just trying to get where we were. And this is NoteInfo. And we're missing a parend here. Okay. Should pass. Info.note duration. Good. Okay, now let's make this test check one more thing. Let's return NoteInfo here. Okay, so this is array of NoteInfo. Well, that's kind of boring. Let's just call that then. Okay, so now I think I can do map $0 note and duration. That should all be the same. Okay. Switch test to use NoteInfo. Okay, now use NoteInfo. Let's what would we call that really? Maybe knows. I think of it as more storing a static derivative of what we did. Okay, so in effect, we're sort of mapping, not in the strict map function sense, but we're mapping a series of symbols to a series of these, and then the timing. This should be time, should be 1, 2, 4. Okay, that's the difference. So I'm extending the same test. This is going to fail on time because we've got all zeros. Yep, okay. SoundPlayer. That's where beat comes in. 1. Duration. Do I have to cast anything? Okay. Beat. Well, I think this, okay, the time is the beat before, and then after we've built this thing, we increase the duration, increase it by the duration of the note. Okay, I think that should be okay. All right. Track duration in NoteInfo. All right, now this, when do we want to convert this? Let's rename this to NoteInfo. Okay. And then now this is where I'm venturing off my claim, my cheating approach to getting out past this tricky type, I guess, to be more accurate. I'm willing to say I can build these. If I had a list of NoteInfos which contains the note, the duration, and the value for time, that I could put this in and build a track that has the right info and then attach it into a sequence and a player. And I need to give it the speed. Okay. And I'm not going to test that. So my contention is if you feed in the notes, I will spit out a player that is ready to go. And that's really the thing we need to keep around. Okay. I think you go on player, you create this thing and you can call start on it. That's about it. All right. Now what we're not doing over here, let's be explicit. This thing right now, it filters out all the rests. Okay, so we're not playing it appropriately. But I'm sorry, excuse me. Not my phone. Okay. Let's see. So I'm not including rests in this setup. Okay. They need to kind of like not generate NoteInfo. They just need to update the duration, I think, is all that goes on, but we haven't tested it. We need to come back and do that. So let's record that here. Create a class to hold note and duration. We've done that. Okay. Even though I didn't expect to. All right. So this is the 14th. Happy Valentine's. Okay, I mean, the first thing we did was spike to get access to MIDI NoteInfo and set tempo. Create class to hold note and duration. We just did that. Convert our events to those. We did that. Well, we're sort of in the middle. Convert, let's say, note events. Okay, convert note to note info. We need to convert rests to note info. Okay, so I'm skipping those with the goal of getting further along on the actual player. Okay, and I think what I want to say is we got to note info. I want something that converts note info to a player. Maybe it's just to player. From note infos of note info. Okay. And it's going to yield this music player thingy. Music player. Okay. Now there may be a bit of a slip here. Missing return. Yeah, opaque pointer. I guess we're not going to return it. We're going to write it. Okay, so var player is music player question mark. Is that how we did that here? Equals nil. Okay. Okay, so given the note info, well, this is where we pull this stuff in. And I want to make it coherent. Can we do player without? Yes. Okay, so player. I don't know. This is the sort of thing where a lot of stuff could go wrong. Player, I think the result of this is a status, right? Okay, so let's do status. And I want to go see this thing. Yeah, thanks. Let's try OS status. Nope. Okay. OS status. Okay. It's a bunch of bad things. Unimplemented full IO. Isn't there one that's like everything's okay? Huh. Here's success. Oh, sex status. How do I get to OS status? Why aren't you clickable? I don't think I'm getting to the bottom of this. They look like a lot of ways to go wrong, don't they? Okay, let's try the query again. OS status codes given the documentation. Okay, it's no error. All right. Okay. Well, okay. Sequence must exist before we create player. All right, let's get the other stuff in here. Gonna try and get the pieces together and then do the work. All right. So I got a music player, music sequence. Well, let's make this 0. I don't know. All these little things with side effects are kind of... ugh. All right. But I think music sequence is an OS status, right? So I'm going to say... Can I say... I don't know. This is... It's a C API. That's how I do it in C, maybe. OS status to expected type int. Now... ugh. Okay, we're not dealing with errors just yet. Maybe that's what I need to do. Okay, what I'm doing is saying if anybody comes back with a non-zero status at the end, I'm gonna look at that and say, things didn't go well. Okay, so we create a sequence. Okay, so create a music sequence. Then we create a track. Okay, then we created a track. And then I think we filled in the track. Right, and we did stuff to the track. Okay, so, but I think we don't have to. I think we can create the player at this point. So that, okay. Okay, so we've got the player, the sequence, and the track. This is redundant. Set sequence we need to do. Do I have to fill in the track first? Well, I'm going to have to do these things just to run it. Okay. We set the sequence to the sequence, set the rate. Okay. And then we do all this stuff. Oh, well, it looks like we can create the player before we create the sequence. Well, let's try it this order and see if it all kind of hangs together. Okay, create the player, create the sequence, attach the sequence to the player, attach the track to create the new sequence, new track. I guess it will attach the track to the sequence. Okay. Then we're going to run through and create the note messages. And this is another status. Equals that. And then times. Okay. So we've put the new events in the track. And now this player is ready. So I'm going to leave this up here and call it music player. Music player. Okay. And then instance member cannot be used on type sound player. Instance member cannot be used on type sound player. Music player, music player. I don't know if I can assign it here. Self.music player equals music player. Okay. And then, okay, so now this is, we don't need to store NoteInfo. We're just going to say SoundPlayer dot, oh, as an instance, right. Right. Ugh. Because this is static. So let's return music player question mark down at the bottom. Music player. Okay, now I can say music player equals sound player dot to player of this stuff. And then I'm going to have a play function. It's going to pass in the speed. And I think this is float 32. We'll have to go check. Okay, so that came in here. Set play rate scalar. Status is that. Let's pass in speed. Let's find this thing. What's he really want? He wants a float 64. Okay. Speed. And then, and again, I'm going to not do anything with status for the moment. We're just kind of pushing our way through. Talking to this external thing. All right, so that starts the sounds on music player. All right. Notice it's hard coding these like we did in our thing, but that's okay for the moment. Let's make a test. And this is kind of a throwaway test. I'm just going to make play, call play. Test, play. Okay. We don't really need any symbols because we're hard coding them. And we're just going to call player.play. 2. Okay. Now, if we've done all this stuff right, this will print us play us a scale. This first, whoops. Okay. Let's back that up a little bit. Is that going to work? This test should still work, and this player should make some noise. Okay. I was hoping to get it done before we called it a day here. Return player. Okay. Let's break here. Is anybody blown up so far? 0. Good. All right. And let's break here. Okay. Okay, it's a thing. Let's print status. Should still be 0. Okay. We'll step out and over. Music player should be that same thing. Yes. Okay. So we got through 2 player. Continue. Okay. Speed should be 4, I think we said, right? 2. Okay. And over. Zero and over. Oh, boom. No factory registered for this ID. Okay, well, that means there's something about doing this that we're not covering. Now there was, where's that thing? Current needs indefinite execution. I think that's only because it's in the playground. Okay, I'm going to take this stuff. Up to the player start. I'm going to do that as a alternate version of this. Yeah, those don't matter. They're just indicating the test code didn't know what it was doing with the statuses either, or didn't want to mess with them. Okay, and then we'll just try that. I don't mind if it blows up there, but I want to stop there. Okay, let's run that test again. Well, since we're here, let's step over. What note number we're on? Okay, I'll just break and continue. Okay, it's got an address. It's kind of real. Right, we set the sequence, we set the rate, and it should play. Boom. Okay. I don't know what this is, but we'll just do a quick check, see if it's some obvious thing. Now they're not even doing, they're doing AV. Oh, simulator. Oh, may not work on the simulator. That kind of sucks. Okay. Swift audio toolbox not working on simulator. Okay. There is a way to do it, but sound works on simulator, but not on my iPad. That's the opposite problem. Yeah, I've done that. Can't play MP3 on a device. Need a different framework. I don't know where that comes from. Okay. I don't think this one's relevant to us. All right, well, we'll stop there. It looks like if we call this in the real app, it might conceivably work. So we'll start there tomorrow. And that's 1 to 3:30 p.m. Eastern Time or 6 to 8:30 p.m. UTC. Thanks for joining. I think we're getting close. And hopefully tomorrow we start hearing some sounds from the real app. All right, take care. Bye-bye.